Physical chemistry, non-ideal mixing enthalpy of acetone and chloroform using the Redlich-Kister model. We will build intuition from chemistry, write the mathematical model, outline a quick statistical fit, and visualize the curve to locate the composition of the maximum exotherm, which means the most negative mixing enthalpy. Chemistry first. Acetone has a polar carbonyl group, and chloroform can donate a weak hydrogen bond. Together they interact strongly, releasing heat when mixed. That heat release means the mixing enthalpy is negative or exothermic. Let's visualize this with a simple interaction sketch. Mathematical model. The Redlich-Kister expansion for a binary mixture writes the excess, or mixing, enthalpy as x times 1 minus x times a polynomial in 2x minus 1. Here is the general form. For a clean illustration, we will keep only the first two terms, A0 and A1. Let x be the mole fraction of acetone, so 1 minus x is the mole fraction of chloroform. Units of A0 and A1 are kilojoules per mole, the same as the mixing enthalpy. Statistics idea. If we have experimental pairs of composition and mixing enthalpy, we can fit A0 and A1 by least squares. We minimize the sum of squared differences between measured values and the model values. This can be written in a linear regression form for the parameters A0 and A1. Here, we will use representative fitted values. A0 equals negative 6.0 and A1 equals negative 2.0 kilojoules per mole. Now, let's graph the mixing enthalpy versus composition and mark the maximum exotherm. That is the most negative value. We draw axes with x from 0 to 1 and delta H from negative 2.5 to 0.5 kilojoules per mole. We plot the Redlich-Kister curve using A0 equals negative 6 and A1 equals negative 2. We add a few experimental points that our model fits. Finally, we mark the composition x star, where the curve reaches its minimum value. To locate the maximum exotherm, we minimize the mixing enthalpy with respect to composition. For n equals 1, we differentiate the model and set the derivative to 0. Here is the derivative. We set it equal to 0 and solve for x star. Using our parameters, A0 is negative 6 and A1 is negative 2, the solution is near x star equals 0.577. At that composition, the mixing enthalpy is approximately minus 1.54 kilojoules per mole. Summary: chemically, acetone and chloroform interact strongly and release heat upon mixing. Mathematically, the Redlich-Kister model captures the composition dependence. Statistically, we fit parameters to experimental data with least squares. Graphically, the composition at the most negative value of the curve gives the maximum exotherm.